The images Cassini sent back revealed a world that looked nothing like its siblings. Roughly 213 kilometers across, almost perfectly spherical. And yet, it looks completely shattered. So what exactly is this thing? Saturn is easily the most recognizable planet in our solar system. And some of its moons are just as iconic. Titan, Enceladus, and Rhea move like clockwork, locked in an elegant dance around this ringed giant. But far beyond that harmony, nearly 8 million miles from Saturn, something drifts that was never meant to be there. It is dark, scarred, and alone. It moves in the wrong direction, crashing against the natural flow of the system, a relic from a time when the giant planets shifted, and the solar system was anything but stable, a world of landslides, frozen carbon dioxide, and a vast, invisible ring of dust so enormous, it dwarfs Saturn itself. This is not just another moon. It is evidence. A captured world, held prisoner for 4 billion years? This is Phoebe. And what we are about to uncover is not just where it came from, but what it reveals about how violent and unpredictable planetary systems truly are. If you enjoy stories like this that uncover the hidden history of our solar system, consider subscribing, because some of the strangest objects out there are still hiding in plain sight. The story of Phoebe begins with a quiet revolution. For thousands of years, astronomy was limited by what the human eye could see. Then came the telescope in the early 1700s, expanding that boundary. But the real shift came later, when light itself became something we could collect, store, and study. In the 19th century, the photographic plate changed everything. For the first time, astronomers could leave a camera open for hours, letting faint light slowly build up, revealing objects thousands of times dimmer than anything Galileo or Cassini could ever have seen. In 1898, at a remote outpost in the dry air of Arequipa, Peru, a team from Harvard Observatory began photographing the southern sky, night after night, plate after plate, searching for something that didn't belong. The process was slow. The plates were shipped across continents, back to Cambridge, where human computers examined them by hand, scanning for tiny changes in the stars. And then, something moved. In 1899, William Pickering noticed a faint speck on a plate from months earlier. It was incredibly dim, about 4,000 times fainter than what the human eye could detect. But that wasn't the strange part. It moved. Over multiple nights, he tracked it. The stars remained fixed. Saturn drifted slowly, but this object followed Saturn, just not like the others. Something about its motion didn't make sense. On March 18th, 1899, the discovery was announced. Phoebe, the first moon ever found not by looking through a telescope, but by capturing light itself. At first, it was a triumph. But as more data came in, that excitement turned into something else. Because Phoebe wasn't just distant, it was wrong. The solar system follows patterns. Everything formed from a spinning disk of gas, so planets and their moons almost always orbit in the same direction. Smooth, predictable, ordered. But Phoebe breaks that pattern completely. It orbits Saturn in the opposite direction, against the entire system, a retrograde orbit, and that changes everything. Because when we see a moon moving backwards like this, there is only one possible conclusion. It didn't form there, and that means, at some point in the distant past, something captured it. If Phoebe had formed alongside Saturn, the surrounding gas would have forced it into a smooth, forward orbit. But it didn't. It moves against the system, and that is a smoking gun. Evidence of something violent, something that didn't belong. Phoebe is not native to Saturn. It is an immigrant, a captured world, pulled in and trapped by gravity billions of years ago. But capturing something like this is not easy. It takes a precise moment, a lost speed, a gravitational interaction that went just right. Otherwise, Phoebe would have simply passed by and disappeared forever. And the scale of its orbit is staggering. Phoebe circles Saturn at an average distance of nearly 8 million miles, almost 4 times farther out than Iapetus, and so distant that Saturn itself would appear as nothing more than a bright point in the sky. One full orbit takes 550 days, a slow, lonely journey far beyond the ordered system of Saturn's inner moons. But that isolation also meant something else. For nearly a century, Phoebe remained a mystery. Even when Voyager 2 passed through the system in 1981, it saw Phoebe only as a distant, irregular shape, a dark fragment, something clearly unusual, but still completely unknown. Everything changed with Cassini, because reaching Saturn required something unusual. The spacecraft had to approach from the outside and slow itself down to be captured, and that created a rare opportunity. Before the critical engine burn, there was a narrow window, a single chance to pass Phoebe up close. One shot, no second attempt. On June 11, 2004, Cassini made its move. For just a few hours, this distant object transformed from a faint dot into a real world, a surface, a history, a mystery unfolding in real time. The spacecraft raced past at over 3.5 miles per second. Too fast to stop, too fast to stay. And just as quickly as it appeared, Phoebe was gone again, fading back into the darkness. But in those few hours, everything changed, because what Cassini saw would rewrite the story of this moon completely. Missions like this don't happen by chance. They are the result of decades of planning, thousands of people, and a single moment that either works or fails completely. And in this case, everything had to work. If you enjoy deep space missions like this and the stories behind them, consider subscribing, because some of the most important discoveries only happen once. What Cassini revealed was completely unexpected. Phoebe did not look like Saturn's other moons. It looked ancient, violent, almost out of place. It is roughly 130 miles across, nearly spherical, but heavily scarred. Its surface is extremely dark, reflecting only about 10% of the light that hits it, almost as black as asphalt. Cassini mapped the surface in detail. Craters upon craters, layered across billions of years. But between them, subtle brightness variations hinted at something hidden beneath the surface. Spectrometers revealed the composition: water ice, carbon dioxide, iron-rich minerals, and primitive carbon-based material, the kind we expect to find far beyond the inner solar system. One feature dominates everything: the Jason crater, a massive impact basin nearly 60 miles wide, almost half the size of the entire moon. And yet, Phoebe survived it, which tells us something critical. This is not a loose collection of debris. It is a solid body with structure, with strength. But the most revealing features were not the craters, but the landslides. Long, bright streaks where the dark surface has collapsed, exposing something much lighter underneath. That changes the picture completely. Because Phoebe is not just rock. Beneath that thin, dark coating, it is rich in ice. A frozen body, covered in a layer of ancient debris only a few hundred yards thick. And the final piece of the puzzle came from something invisible: gravity. As Cassini passed by, scientists measured the tiny pull Phoebe exerted on the spacecraft. From that, they calculated its density, about 1.6 grams per cubic centimeter, and that number changes everything. Most of Saturn's moons are made of light, porous ice, low density, fragile. But Phoebe is different. It is far denser, containing more than half rock, and that single detail changes its entire identity. Because objects like this don't form near Saturn, they form far beyond it, in the deep outer solar system, in the same region as Pluto, as Triton. This suggests something remarkable. Phoebe is not just a moon, it is a planetary embryo, a world that began forming like a planet, separating into layers, a rocky core, an icy outer shell, but never finished. And then came the chemical evidence, carbon dioxide, locked into its surface, a volatile compound that should not survive near Saturn, but out in the deep cold, it can remain for billions of years. Which leads to one unavoidable conclusion. Phoebe formed far beyond Neptune, in the Kuiper Belt, a distant, frozen region filled with ancient debris, and somehow it made its way here. But capture was only the beginning of its story, because even now, Phoebe is still changing the Saturn system in a way no one expected. For billions of years, it has been bombarded by micrometeoroids, tiny impacts, over and over again, each one blasting small amounts of dark material into space. And because its gravity is so weak, that material doesn't fall back. It escapes, spreading outward, forming something much larger. Over time, that dust built up into something enormous, a structure so vast it went completely unnoticed until 2009. Using the Spitzer Space Telescope, scientists discovered it, the Phoebe Ring, and its scale is almost impossible to grasp. It stretches from about 4 million to 10 million miles from Saturn, a structure so large you could fit around 1 billion Earths inside it. And yet, you cannot see it, not with your eyes, because the dust is spread so thin it reflects almost no light at all. The only way to detect it is by its faint heat, a barely measurable glow in the infrared. And one detail makes the connection undeniable. The ring is tilted by 27 degrees, exactly matching Phoebe's orbit, which means this entire structure, millions of miles wide, exists because of one small, captured world. The ring doesn't just align with Phoebe, it moves like it too, a shared retrograde motion, and its composition matches perfectly, the same dark, primitive material covering Phoebe's surface. This wasn't a coincidence, it was confirmation. Phoebe is creating this structure. Over billions of years, countless tiny impacts have slowly built a vast, invisible halo, stretching millions of miles across space. And with that, a mystery that lasted centuries was finally solved. In 1671, Giovanni Cassini discovered a strange moon, Iapetus. One side bright as snow, the other dark as coal, a perfect split, no explanation. But now, the answer is clear. Phoebe orbits backward. Iapetus moves forward. And as dust from Phoebe slowly spirals inward, it collides directly with the leading side of Iapetus. Over time, that dust builds up, layer by layer, darkening one hemisphere, while the other remains untouched. Phoebe is painting its neighbor from millions of miles away. A single captured object, reshaping another world, and that raises a much bigger question. How did it get here in the first place? The leading explanation points to a chaotic past. Around 4 billion years ago, the giant planets did not sit where they are today. They moved, interacted, destabilized everything around them. In that chaos, the Kuiper Belt was disrupted. Countless icy bodies were scattered. Some were thrown into deep space. Others fell toward the sun. But a few were captured. Triton, Phoebe, worlds that never belonged, now trapped as moons. And if it happened here, it is likely happening everywhere. Phoebe is not just a moon. It is a relic, a surviving fragment of the material that built the outer solar system, preserved for billions of years in the cold grip of Saturn. But even now, we don't know everything. What lies beneath that dark surface? Did it fully separate into layers? Can we trace exactly where it came from? Because Phoebe is not just telling us about itself. It is telling us how planetary systems really form. Not calm, not ordered, but chaotic, violent, and unpredictable. And that changes how we see everything. Every moon, every planet, every system we observe beyond our own. Phoebe is still out there, orbiting in the wrong direction. A silent reminder that not everything in the universe formed where it belongs. So the next time we discover a distant moon, how do we know it was ever meant to be there? Thank you for watching. If you found this analysis valuable, consider subscribing for more deep space insights. And as always, stay curious.